it's important to remember that a pump doesn't operate on its own. It operates as part of a fluid system. Now, that system is going to operate where the system curve, that's the head loss and flow rate condition, intersects with the pump curve. And this is the stable operating point. A slight increase in the flow rate would lead to a higher friction loss, so the flow would decelerate back to the operating point. If the flow rate decreased a little bit, then the friction loss would be lower and the flow would accelerate back up to its operating point. So in order to correctly size a pump to match our system, we need to know the system. Now, what is the goal of the system? Are we trying to provide a particular head and any flow rate is fine? Are we trying to provide a specific flow rate and we need enough head to do that? What are we looking for? So you perform your system calculations and you find the head and the flow rate required. Then you need to look at the pump class graphs, and you need to find a pump that's going to work for your application. Once you have the right pump class, or the right pump design, you go to the pump curve for that particular type of pump. Now, there may be 2 or 3 pump classes that would work for your system. All of these are technically correct, but one of them will be the best answer, right? It'll have the best performance, the best efficiency, and so on. So what do you look for? You want to find the pump rotor that operates closest to its best efficiency point. So you want the pump that you're using to be operating as you want the head and flow rate condition for your system to be as close as possible to the best efficiency point for the pump that you're using. This will help reduce energy costs, and it may also help increase or improve the maintenance costs. And then you have one more check. You need to make sure that the net positive suction head available is enough. It's got to be at least 10% higher than the net positive suction head required. Now, fully characterizing these pumps requires experimental measurements, but the ideal analysis techniques that we've used in this module help us to narrow our search. We could use the Euler turbomachine equation to estimate the rotor diameter or the blade angle that we're looking for. This means we could have fewer pumps to search through. Once the pump is selected, we then need some additional data to select a motor to drive the pump. We need to know how much torque the motor has to supply to the pump. We need to know the hydraulic power required from pump theory. We need to know the efficiency from the pump curves to give us the mechanical power that the motor must produce in order to deliver that hydraulic power to the fluid. Basically, we need to know the pump efficiency. And then if we want to determine the input power, the last thing we need is actually the motor efficiency. So that'll tell us how much electric power or how much fuel consumption is going to be required for our application.